All right, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. This one I think will be fairly short because just like on 51, this one is two different things in the numerator and the denominator that are both fairly simple functions. The numerator is an exponential function and the denominator is a factorial. When you're just comparing basic to basic here, it's fairly easy to compare them. A basic exponential that I would say is like anything with a base of more than one going to the power of n over a factorial, a standard factorial. So like into the in with the exclamation mark on it. Anytime you have that kind of thing happen, the limit is basically zero because the bottom is going to infinity faster than the top. Now, if you need to show that, you can do that a couple different ways. On the last video, I was showing you the hierarchy of the different kinds of functions and how fast they go compared to each other. On this video, I think I'll skip doing that because if you want to see that, that was on the last video, 51. You can also see a whole video on the hierarchy of functions, and I list out a bunch of different ones. If you have trouble finding that, just let me know in the comments below, and I can go look it up. But I think a simple t-chart would probably be fine. It really would take a while for it to start to take off because if n is 1, we would end up with 1,000 over 1,000 factorial, which actually, oh no, hold on, that would be 1 factorial. JK LOL. And 1 factorial would just be 1. So that's still 1,000. That's a pretty big number. And then we would get 1,000 squared, which actually 1,000 has 3 zeros, so that's 10 to the third power. So another way to write it would be 10 to the 3n power. So it would just be 10 to the 6th power. So another way to write it would be 10 to the 3n over n factorial. So 10 to the 6th power over 2. Still pretty big. And the top is growing much, much faster than the bottom, right? So it's going to take a while for it to catch up. 3 factorials, that's going to be 6. But by the time we get to like some really big numbers, let's see if I can look up something that's a little bit larger. Let's go by factors of 10 now. So if I type it in as a function, I'm going to write f of x. I'm typing in Desmos over here. F of x equals 1,000 to the x power over x exclamation mark. And yeah, so it's going to increase for quite a bit. It looks like it's going up. Wow, I can't even see the graph anymore. That's crazy. Yeah, so it looks like it is taking off, and with no end in sight, basically. So let's maybe start by like factors of 100. Go by factors of 100 here. So f of 100. So that's a pretty big number. F of 100, if we go to 100, 100, been a little laggy here. There we go. F of 100 is about 1.07 times 10 to the 142 power. Yikes. Okay, then what about 1,000? Undefined. Okay, so it's not liking, it looks like it's going to take a while for it to come back down. So the other thing I can do too is if you need if you need something to use more computational power, I would recommend Wolfram at that point. I was using Desmos, which is good for most things, but Wolfram Alpha has a lot of calculational power, so it can calculate things that that normally couldn't happen on either Desmos or maybe even like Mathway. I know there's some things that just you can't calculate on either of those. Wolfram has more calculational power, so I want the limit as n goes to infinity, and I'm literally just typing it out because it'll know what you're trying to say. most of the time, it can tell pretty much everything and just write it in regular words like a prompt. Limit as n goes to infinity of, and then we want 1000 to the n power divided by n factorial. And I'll go ahead and hit enter, but I want to double check that it got that right. Yeah, it did. So it was the limit as n goes to infinity of 1000 to the n over n factorial, which is 0. So it is able to calculate it on Wolfram, and we're able to double check it on there. Desmos is just not able to handle it. They are just not able to handle it because it takes a long time for it to catch up. The factorial is faster, but because the exponential has a lot of initial power, it takes a long time for it to catch up before it finally takes up, catches up and then ends up taking off. One last thought on that is, if it's not really obvious from a T-chart, just think about okay, so a factorial, an exponential will times by itself over and over, right? So 1000 times 1000 times 1000 times 1000. Well, in factorial will times by every number before it as well. So if I want 1000 factorial, that's 1000 times 999, which is pretty close to 1000, times 998, times 997, and you keep doing that over and over and over until you get down to 1. So 1000, even multiplied by itself, wouldn't be the same thing as 1000 factorial, not even close. So even though it takes a while for it to catch up, it eventually does catch up, and then it would start to, come back down and level out at 0. Maybe one way to think about it would be, let's say you're going to run one lap around the track, and you have a sprinter versus somebody on a road bike. But the road bike is set to the highest gear already, right? The hardest gear to pedal, which is normally what you don't want to do because you'll start off really, really slow. But you could do that in theory. You'd start off really slow, right? But a bike is faster than somebody running, period. I don't care how much, what stamina everybody has. You're just assuming infinite stamina basically at this point. But one lap around a track, right? So the sprinter would take off right when they say go. The sprinter's going and he's gone, he's booking it, and the bike is going a little bit, but he's not catching up. But the bike eventually gets faster and faster and faster and faster, but the runner will reach his 100% within a few seconds, usually 3-4 seconds or so, and then he's going as fast as he'll go. And if he's able to hold that whole lap around the track, awesome. But the bike will keep getting faster and faster and faster, and eventually it'll be going faster than the runner, and then that's when it'll start to catch up, and probably within a lap it would be able to catch up, maybe 2, depending on how fast the runner is and or how fast the biker is. But you see how that kind of works. So even though the 1000 is way taking off, the n factorial with enough time will catch back up to it and win out. So the limit of this is infinity, so it converges, and it converges to 0, and that's the final answer. Go ahead and check out the 5 math mistakes everyone makes and how to avoid them. It's a free PDF guide on my website, myersmathematics.com, link in the description below. And I'll catch you in the next video. Blessings, y'all.